Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss on a circuit called differentiator circuit. Using op-amp, a differentiator circuit is a circuit in which the output voltage will be a differential value of the input voltage. In our previous video, we have already discussed about differentiator circuit using BJT. Yes, circuit this manner with input voltage fed to the inverting terminal of the circuit. Capacitor CF, feedback resistor, input signal, current IC flows through the capacitor, and IF, IB is the bias current, RF, and RL resistor. So the output voltage of this circuit is equal to minus RFCF into differential value of the input voltage. Do we get that? Yes. This is an ideal differentiator circuit. To make it more practical, we are going to connect a capacitor parallel to the resistor and another resistor in series with the capacitor. Yes. So this pair forms a impedance and this pair forms impedance. Yes. So analyzing in this manner, we could calculate the value of the output voltage. F naught is equal to 1 by 2 pi RF into C. Since IB is equal to 0, IC is equal to IF. The capacitor current and the feedback current will be equal to 0. C into D by dt into Vin minus V2 is equal to V2 minus V0 divided by RF. C into dVn by dt is equal to minus V0 by RF, or V0 is equal to minus RF into C into dVn by dt. Since V1 is equal to V2 is equal to 0 volts, V0 is equal to minus RF into C1 into dVn by dt, and Fa is the frequency at which the gain is obtained. So the frequency response gain of a differentiator circuit is taking the gain on y-axis and the frequency on x-axis. The maximum gain, yes, this is the curve obtained. And This is the gain obtained under open loop, and the gain increases with the frequency. This is the gain obtained under closed loop. The closed loop response of a practical differentiator at minus 20 dB per decade. Yes, so here both the stability and the high frequency noise problems can be corrected by the addition of two components, R and C. This circuit is a practical differentiator circuit, the response of which we have discussed now. The gain limiting frequency FB is R1 C1. R1 C1 is equal to RFCF. They help to reduce significantly the effect of high frequency input, amplifier noise, and offsets. Above all, it makes the circuit more stable by preventing the increase in gain with frequency. Generally, the value of FB and in turn R1, C1 and RFCF values should be selected such that the initial frequency FA, FB and FC are lesser. The gain of the circuit increases with the increase in frequency at a rate of 20 decibels per decade. This makes the circuit unstable. Also, the input impedance XC decreases with increase in frequency, which makes the circuit very susceptible to high frequency noise. When amplified, this noise can completely override the differentiated output signal. Hence, the frequency is equal to, as discussed in the previous slide, F is equal to 1 by 2 pi RF into C1. Yes, this is all about a differentiator circuit using op amp. Thank you.